Hello everyone, I'm Nishant KP from batch B1. I'm doing this seminar under guidance of Assistant Professor Bharat Kumar sir. My topic is Smart IoT device for child safety and tracking. Coming to the content part, we have introduction, literature survey, methodologies, component used, flowchart, system analysis, connections, advantages, disadvantages, result, conclusion, and future scope reference. So, coming to the introduction first. Basically, children cannot complain about abusement which they face in their daily life to their parents. They can't even realize what actually happens to them at their age. It is also difficult for parents to identify their children are being abused. Since to prevent children before being attacked, an autonomous real-time monitoring system is necessary for every child out there. In this system, the collected values from their sensor like temperature sensor, pulse rate detection sensor, mental detection sensor, and location value from GPS are used to detect the status of the child and alert the respective guardians using GSM accordingly. Coming to the next part, the literature survey. First, coming to the first literature survey. First one is RFID based system for school children transportation safety enhancement. This paper, a system to monitor pickup or drop off of school children to enhance the safety of children during daily transportation from and to school, from home and to school. The system consists of two main units, a bus unit and a school unit. The bus unit, the system is used to detect when a child boards or leaves the bus. This information is communicated to the school unit and identifies which of the children did not board or leave the bus and issues an alert message accordingly. The system has a developed web-based database-driven application that facilitates its management and provides useful information about the tested to validated the system functionality. The result shows that the system is promising for daily transportation system. Coming to the second literature survey, it's the design and development of an IoT-based wearable device for the safety and security of women and girl child. The aim of which is to develop a wearable device for the safety and protection of women and girls. This objective is achieved by the analysis of physical signal in conjunction with body position. The physiological signals that are analyzed are galvanic skin resistance and body temperature. Body position is determined by acquiring raw accelerometer data from a triple axis accelerometer. Acquisition of raw specialized machine learning algorithm. Real-time monitoring of data is achieved by wireless sending sensor data to an open source cloud platform. Analysis of the data is done on MATLAB simultaneously. The device is programmed to continuously monitor the subject parameters and take action when a dangerous situation presents itself. It does, the, it does so many detect detecting the change in the monitored signal, following which appropriate action is taken by means of sending notification or alert to the designated individual. Coming to the third literature survey, it's the child safety wearable device. Parents need not to have smart mobile. Set of keys are used to gain information from the kit. Location keyword is used to obtain the location of the child. UV keyboard is used to obtain the temperature of the surrounding. Buzz keyword is used to turn on the buzzer which is fixed in that device. SOS is used to send a signal to the device. That's how it communicates the parents or the guardians from the child. So coming to the fourth literature survey, it's the smart intelligent system for women and child security. A portable device which will have a pressure switch as soon as the assailant is about to attack person or when a person senses a insecurity of a stranger, he or she can put a pressure on the device by squeezing or compressing it instantly. Instantly, the pressure sensor senses the pressure and conventional SMS with the victim location will send to the parents or guardian cell phone number, which is stored in the device by purchasing it, followed by a call. If the call is unanswered for the prolonged time, a call will be redirected to the police and same message will be sent. Additionally, if person crosses some area which is usually not accessed by the person, then a message with the real-time location is sent to the parents and guardians via conventional SMS. So these are the literature survey. So coming to the methodology. First, the first methodology is define major project goals. So all the goals of a project is to be defined firstly, and then the derive project requirement from goals. The project is derived from the required project. What are the goals of the project which we need to accomplish or derive? Then we need to design system architecture. This design system architecture is where we design the whole part of the project where architecture diagrams are made and using that architecture we design the system. Next coming to the define user experience flow. That means the user experience flow, how the flow of the user working takes place is to be defined. Then identify development stages. So we need to identify what are the stages that are used, that are needed to be taken or need to be done during this development process. Then, then is the assemble and code each stage. After segregating each and every part of the project, we need to assemble the required systems and need to code as what the expected result should be. What we required, we're gonna code it in this stage. And in next, integrate development stages. We need to integrate whatever the code we have coded to the system. We need to integrate by integrating on the system. Then after integrating of the developed project, we need to test and troubleshoot whatever the errors or debugging should be done will be done in the test stage. If all the criteria is passed in the test case, then we get the project completely, or else we need to debug and start it over from again from the assemble and code stages, and later on coming to the integrating part and then again testing it. So these are the methodology. And coming to the components, the components are coming to the first component. This is the GPS module. These tiny devices can instantaneously give your exact position and time almost anywhere from the planet for free for free. All of you all that you need is that the GPS receiver. That's it. Then coming to the second component, it's the GSM module. The GSM module is used for connecting the device to another GSM device, enabling IoT connectivity and remote monitoring. This module will send data to the registered set of devices and cloud for analytics. Coming to the third sensor, that's the touch sensor, uses a unique combination of infrared distance sensing, pressure sensing, optical encapsulation, and data filtering to detect extremely light touches, and additionally, silicon covering is squished, giving the sensor increased grip function. This sensor is mainly used for touching sensing. Coming to the next sensor, that's the temperature sensor. It's a low voltage, precious, integrated, centigrade temperature sensor. It provides a voltage output that is similarly proportional to the Celsius temperature. It also doesn't require any external collaboration to provide typical accuracies of plus to minus degrees Celsius at plus to minus plus 25 degrees Celsius and plus to minus 2 degrees Celsius over the minus 40 degree Celsius to plus 125 degrees Celsius temperature range. The pulse sensor. The pulse sensor is used to measure the heart rate of an individual. Then, coming to the flow chart. So, in the flow chart, we explain the data flow or the workflow of the project, the flow chart of the proposed system. The counter should be started for counting time. The sensor output data should be read from the child safety device. For every 30 minutes, exact serial camera, the data from the GPS temperature, touch, pulse data is pushed into the cloud. The sensor data is continuously read by the controller. When the value of the temperature read from the sensor across the threshold one notifies the message is sent. That's how it works. The the flowchart starts like this. First, the control will start. The control is started. Then it reads the process output data, all the GPS, the touch, the pulses, and the heartbeat, all those data from the sensor. First, coming to the count of the counter, where every 30 minutes is checked. Then after checking, if no data is recorded, it throws no. And then if any activities has recorded, it comes to the next stage. Then in this, the temperature is checked. When it crosses the threshold, it reports yes. or as nothing. Then again it comes to the touch sensor. If the value is greater than the threshold, it throws yes, and if it's not, it throws no. Again, if it checks the pulse sensor, the pulse rate. If the threshold is higher, then it is, returns yes, or else it's no. Then go back again to the read the process state. If everything satisfies as yes, the SMS is sent, and also the photo is captured and sent. And coming to the system analysis, we can see the graphical representation of the touch sensor where it calculates all the touch sensing values where all the points are recorded, and whenever this graph value goes higher the threshold, the message is sent. So coming to the temperature sensor graph, you can see the graph with all the recorded temperature with time and with the values. Whenever this threshold value increases, it sends the message. So coming to the pulse sensor graph. So these are the pulse rate which are recorded with time and also with the location of it. Whenever the uh, pulse rate threshold is increased, then message is sent. So the pulse rate is converted into beat per minute. Calculation is so below. See, the beat per minute is equal to point 1.0 divided by pulse interval, the interval of the pulse, then intoing 60 and intoing 1000 pulse rate in a graph of adult person. So the value gives you 735. The BPM, the that means the value is divided by 735 by 1 divided by 735 into 60 into 1000 and giving you the value of 81.63. The pulse rate of the child decrease, then the BP increases, BPM, then the BPM increases. Whenever the pulse rate value is less than 400, then automatically send an SMS alert to the mobile, and also an MMS is sent to the parent's mobile module, which consists of an image indicating the surrounding area of the child. So these are the connection. This is the connection of the our project where you can see the camera module, the pulse sensor, the touch sensor, the GSM module, and the GPS module. It's connected, and the circuit connection are shown here. So advantages: parents can define a perimeter for their kids when they go outside. As soon as they step beyond the defined area, the tracking software will alert you. The idea is not to deter my your children's freedom, but to ensure that you know how far your kid has gone. It is very easy to lose sight of your kids in public areas. It is suggested to never leave them alone untended, but in such situation, the GPS tracking can help you easily locating them. The GPS watch can also be used in case you think a mishap may have happened to your child. Apart from real-time tracking, you can easily pinpoint the location of your child may have been to. This gives you the lead right away if your kid goes missing. GPS tracking can also be beneficial when it comes to older children. Once again, this is not about mistrust and restricting independence. Teenagers can often get involved in activities parents may not approve of. It is okay to let them discover, but with GPS watch, they can push emergency button to alert parents about any mishap or bad situation they may stuck in. So coming to the disadvantages, it if you are using GPS on the battery operated device, there may be battery failure and you may need an external power supply which not always possible. Sometimes the GPS signals are not accurate due to some obstacles to the signal such as building, trees, and sometimes by extreme atmospheric conditions such as geomagnetic storms, weather, and traffic alert. Depending on which device you use, the GPS may provide weather and traffic alerts. This alert informs you to advise weather or traffic condition. So the result, one of the module in your project is temperature sensor, which is used to detect the temperature of the child as well as the surrounding temperature. If there any occurrence of abnormal rise of or fall in temperature in the body of the child or in the surrounding, it will notify the user as per coded time delay as shown in the picture. It will show the temperature and humidity values notify the user based on the predefined value, abnormal fall or rise in scenarios. Come to the conclusion and feature scope. This research demonstrates smart IoT device for child safety and tracking, helping the parents to locate and monitor their children. If any abnormal values are read by the sensor, then an SMS is sent to the parent's mobile and an MMS indicates indicating the an image captured by the serial camera is also sent. The future scope of the work is limited implement the IoT device which ensure complete solution of the child safety problems. This may include all those issues which may occur while in the GPS location, where the tracking of GPS location may not be exactly at at specific uh, places where the uh, towers are not nearer to the places where such challenging places like a forest and all. So the future scope you can overcome it. So these are the references. The first one is the standard T, Shiley, B, and Pentaland. The visual contextual awareness in wearable computing. This is the book. And the second one is Akash Modipiri Pitri Hamid Shan Nazar, which the book is Child Safety Wearable Device. Coming to the third one, Aspita Pawar, Pratiksha Sagar, Tejal Shasane, Kiran Shinde. The book Smart Security Solution for Women and Children Safety based on GPS using IoT. Next, Nitishri, published on June 2016, a review on IoT based smart GPS device for child and women safety. Come to the fifth one, Kok Sun Wong, Wei Long Nung, Jin Huang Chang. This is the Chinese author which published GPS-based child care system using RSSI technique. So that's all about the project. Thank you.